Hello students, welcome back to maths class. Today we will start one new chapter, right? Definite integrals. It is the continuation of integrals. It is the continuation of integrals. If you are perfect with the integration, we can easily solve definite integrals. Continuation means we will use all the formulas, all the concepts, but this is separate unit and it contains 15 marks, right? One 7 marks question, one 4 marks question, 2 marks question, 2 marks question. Okay, so now come to the definition. So what is definite integral means? If a to b f of x dx, integral a to b f of x dx, we will get, after this integration, we will get one function and we have to write these values, a to b values, right side a to b. In that function, wherever x is there, first we have to substitute upper limit minus wherever x is there, we have to substitute lower limit. Okay, so that is our definite integral. See, if f of x, capital F of x is an antiderivative of a function f of x defined on open interval a comma b, then this is called the definite integral of f of x. We will write like this. So what is the difference? You know integral f of x dx already, you know it. Here it is a b, right? So what is a b? A is called the lower limit and b is called the upper limit, right? Integral a to b f of x dx is equal to, we can take after integrals, we will get one function, that function as f of f, capital F of x, and it is a to b. In this function, in x place, first we have to substitute upper limit and in x place we have to substitute lower limit. And this one here, integral a to b f of x dx is called definite integral of f of x from x is equal to a to x is equal to b. Okay, so a is called the lower limit and b is called the upper limit. What is the difference between your integral and a definite integral means? Here we will have the bounds, right? So we have to find out the integral of this function from x is equal to a to x is equal to b. That is the meaning. Okay, we have to find out the integral of this function from x is equal to a to x is equal to b. So this a is called the lower limit and b is called the upper limit, right? So that's why in this function, after the integration, we have to write right side the values. We have to write right side the limit values a to b. After that, in the derived function, right, wherever x is there, first we have to substitute upper limit minus in that function wherever x is there, there we have to substitute lower limit. Okay, so here integral a to b f of x dx is called the definite integral of f of x from x is equal to a to x is equal to b. So a is called the lower limit and b is called the upper limit. Small a is called the lower limit and b is called the upper limit. Next come to some standard formulas, fundamental properties of definite integrals. First, integral a to a f of x dx, right, is equal to 0. If lower limit and upper limit both are same, right, then for that integral value will be equals to 0, right? So if lower limit and upper limit both are equal, right, a to a f of x dx is equal to 0. Next, a to b f of x dx can be taken as minus of integral b to a f of x dx. That means if we change the limits, we will get the negative sign. If we change the limit, we will get negative sign. Next, integral a to c f of x dx can be written as integral a to b f of x dx plus b to c f of x dx, right, where your b lies in between a and c. Then we can split this integral into two parts. Next, integral 0 to a f of x dx can be taken as integral 0 to a f of a minus x dx. We can take f of a minus x dx. Next, integral minus a to a f of x dx is equal to, we can take 2 into integral 0 to a f of x dx if f of x is even, right? Otherwise 0 if f of x is odd. These are the main 5 formulas we are going to use in this definite integral. Now come to first exercise, exercise 7a. In 7a we are having very simple problems so that you will get used to this process of definite integrals. What is the procedure of definite integrals? First we have to integrate the function. Next, in that function right side we have to write the limits. Next, in that function in x place, first you substitute a value minus b value. Okay, so come on, first we will take first question, integral 0 to 5 x plus 1 dx, 0 to 5 x plus 1 into dx. Okay, so how we can write? Take it separately, plus is there, right? So we can take, whenever plus is there we will take separate integrals. So it is 0 to 5 x dx plus integral 0 to 5 1 dx. Okay, so is equal to, we can write, you know that this is x to the power of 1 form. So we can write x to the power of 1 plus 1 by 1 plus 1. After the integration, right side we have to write the limits, plus integral 1 into dx, integral dx is x. So it is 0 to 5. So come on, what is this? First observe, we are having 0 to 5 x plus 1 into dx. So we can take that as x to the power of separated, just plus is there. So we can take separate integrals. You know it very well in integrals. So now we have to integrate this one, x to the power of n form. Integral x to the power of n is x to the power of n plus 1 by n plus 1. Once formula is applied, we have to take the limits in right side. Okay, so next here integral 1 into dx, integral dx is x, and you can take the limits 0 to 5. You can take the limits 0 to 5. So is equal to, come on, how we can take? Now this is x square by 2 into 0 to 5 plus, this can be taken as x as 0 to 5. Now what I said, after writing right side in x place, first we have to substitute the upper limit minus lower limit. So come on, we can take this as y square by 2 minus 0 square by 2. Okay, so next plus, we can take this as upper limit 5 minus lower limit 0. So is equal to, how much it is? 25 by 2 minus 0, no need to write, plus 5 is equal to 2 is the LCM, 25 plus 2 5 is 10 is equal to 35 by 2. That's all. Actually first exercise problems are very simple problems so that you will get used to this procedure. Now come to the second question, 0 to 4 x square dx. So come on, x to the power of n form. So we can take x to the power of n plus 1, that is 2 plus 1 by 2 plus 1. Once we applied the formula, we have to take the limits on right side. Right, here it is 0 to 4, you take the limits on right side. So is equal to, it is x cube by 3 into 0 to 4. Okay, so in this function in x place, first upper limit minus, in the function in x place we have to substitute lower limit. So 4 cube by 3 minus 0 cube by 3. So 4 4s are 16, 16 4s are 64 by 3 minus 0, that is 64 by 3 is the answer. Okay, so now come to the third question. What is your third question? Simple questions, no? Actually, so that you can get used to this procedure. What is the procedure? First, we have to integrate the function. Once function is integrated, you take the limits on right side, right? Wherever the function is there, x is there you substitute the upper limit first, right? Minus in that function only wherever x is there, you substitute 0. That is definite integral. The difference between the indefinite and definite integral is here you are getting the bounds, limits, right? We have to take x values from 0 to 4. That is the meaning. X value limits are lower limit, upper limit. So your x values are from 0 to 4, right? That's why we have to substitute in the derived function wherever x is there. First you substitute the upper limit minus in the derived function wherever x is there you substitute lower limit. Okay, so now come to the third question. What is it? It is 0 to 4 x plus e to the power of 2x into dx. In all these problems, if you observe, we are having, right, upper limit, lower limit, and dx will be there. So normal integral, but here bounds are there. That's why if we apply the bounds, we will get a definite value. That's why it is called definite integral. In previous, it is indefinite. That means for each value we will have plus c, plus c, plus c. But here we are getting some definite value. See, we got 35 by 2, we got 64 by 3. Some definite value we are getting. That's why these are called definite values. That too, it is its limits also we know from which value to which value we have to find this function, right? From x is equal to 0 to 4, like that we have to find. So now come to the third question. So same thing in third question also, whenever plus minus is there, we can take separate integrals. So come on, is equal to, it is 0 to 4 x dx, okay, plus, come on, integral 0 to 4 e to the power of 2x into dx. So how we can solve this one? Is equal to, you consider this as x to the power of 1. So x to the power of 1 plus 1 by 1 plus 1, that is x square by 2. After applying the formula, we have to take the values on right side. Similarly, here we can take e to the power of 2x by 2, right? So we can take 0 to 4. Okay, once we applied, which formula we applied here? It is integral e to the power of ax dx is equal to e to the power of ax by a. Okay, that's why integral e to the power of 2x dx is equal to e to the power of 2x by 2. So e to the power of ax by 2. We have to write according to that formula, right? Once it is over, we have to substitute the bounds in the given function. First, upper limit. So come on, how? What is your upper limit? It is 4. So we can write 4 square by 2 minus lower limit 0 square by 2. Okay, plus next we have to take e to the power of 2 into 4. 2 4s are 8. 8x by 2 minus e to the power of 2 into 0. 0 by 2. So any value to the power of 0 is 1. Right? Any value to the power of 0 is equal to 1 in mathematics. So this value is 1. Okay. Here 4 square means it is 16 by 2 and this is 0 plus, come on, e to the power of 8x by 2 minus 1 by 2. E to the power of 0. E to the power of 0 means 1. Any value to the power of 0 is 1. So it is 1 by 2. So is equal to 2 is the LCM. So it is 16 plus e to the power of 8x minus 1 is equal to 16 minus 1, 15, right? So 15 plus e to the power of 8x by 2 is the answer of your third question. So simple formulas, just if you know integral formulas, after that just we have to apply, we have to substitute the bounds, right? So first upper limit in the derived formula minus lower limit in the derived function. In place of x, we have to substitute upper limit minus, in the same function in place of x we have to substitute lower limit, that is definite integrals. Okay, so at the end we will get some definite value, and also we know from which place to which place we have to find that integral value. That's why it is called definite integral. Okay, now come to the fourth question. What is your fourth question? Integral 0 to 1, it is x into x square dx. Okay, so is equal to 0 to 1 x dx minus 0 to 1 x square dx. So come on, both are in the form of integral x to the power of n dx form. So it is x to the power of n plus 1 by n plus 1 form. Okay, so here we don't take c, why? We have to substitute the values, right? So some definite value is there. So come on, for this it is x to the power of 1 plus 1 by 1 plus 1 minus x to the power of 2 plus 1 by 2 plus 1. Once the integration over, we can take 0 to 1 and here 0 to 1. Right side we have to write. After taking the formula, we have to take right side, right? So is equal to, come on, what is this? X square by 2, right side 0 to 1 minus x cube by 3, right side we have to write 0 to 1. Remember this, after applying the formula, right side we have to take the limits. After that, in that function, wherever x is there, in that first substitute upper limit minus wherever x is there, you have to substitute lower limit. So 1 square by 2 minus 0 square by 2, okay, minus, come on, 1 cube by 3 minus 0 cube by 3. Okay, so is equal to 1 by 2 minus 1 by 3. Okay, so it is 2 3s are 6. So 3 minus 2 is equal to 1 by 6 is the answer of this question. Okay, so very simple. So definite integrals, right, means just first we have to take the formula normal by our integration. What is the difference between a definite integral and before integrals? Integrals means they are said to be indefinite integrals, means there we don't know the limits of x value. That means where we have to find from which value of x to which value of x we have to find that function value. We don't know in indefinite integrals, but in definite integrals you will know you have to find integral of this function from x is equal to 0 to x is equal to 5. Here x is equal to 0 to x is equal to 4. So it is called the lower limit, that is called the upper limit. Okay, so now come to first question, 0 to 5 x plus 1 into dx. So 0 to 5 x to the power of 1 into dx plus 0 to 5 1 into dx. Okay, so which form it is? Integral x to the power of n, right? Most repeated formula in integral I said, isn't it? So in that form, so we will take x to the power of n plus 1 by n plus 1. Once formula is taken, right side we have to write the limits. And integral dx is x, so 0 to 5. Okay, so now here after taking this, in this first in x place upper limit you have to substitute minus in the given function wherever x is there you have to substitute 0. Similarly here also 5 minus 0. Simplify. Same thing with the other problems also. Okay. So whenever plus is there, we have to take separate integrals, just like our integration differentiation. Plus minus is there, we will take individual derivatives, separate derivatives, separate integrals. In derivatives, separate integrals also separate we will take. After that, same rule we have to apply. After applying the formula, right side we have to take the limits. Then in the function, wherever x is there, first upper limit minus, in the entire function wherever x is there, you have to substitute the lower limit and simplify. At the end, you will get one definite value, that is your definite integrals. Okay. So you will have the lower limit, upper limit. Okay. So first find out the integral by using our normal method, then write the limits in right side. After that, substitute upper limit in place of x in the function minus, right, substitute the lower limit x value, right, in the function. Okay. So upper limit minus lower limit and simplify, you will get some definite value. Okay. So that's why it is called definite integrals. Okay. And the most repeated formulas in definite integrals is, if limits are same, upper and lower, then that function's integral value becomes 0. If we interchange the upper and lower limits, then we will get minus sign for that integral, right. And suppose a to c, suppose we want to find the integral from a to c f of dx is there, and b, one number is there in between a and c, then we can split this integral into two integrals, from a to b f of x dx plus integral b to c f of x dx. Next, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx you have to find. Okay. So next, integral minus a to a f of x dx value is 2 times of integral 0 to a f of x dx if f of x is even, right, is equal to 0 if f of x is odd. Okay. So these are the 5 most repeated formulas we are going to use in this entire chapter. Okay. So be perfect with the concept. Okay. So don't by heart each and every step, very simple. If you practiced the integrals perfectly, then this will be very easy chapter for you. Integrals means that will be the starting, that means you never got that topic in your previous classes, but now you gone through the integration. Once integration over, this will be very easy topic. Okay. So be perfect with these formulas and concepts and practice these problems. Okay. So that's all for today. Have a nice day.